Hi guys, and this is Prade, and today I'll be showing you my version of CS50's Intro to AI Project 6 Parser. Well, a common task in natural language processing is actually a technique called parsing. This is the process of determining the structure of sentence. It's useful for a myriad number of reasons. For example, knowing the structure of a sentence can easily help a computer to better understand the meaning of a sentence, and it can also help the computer to extract information out of a sentence. But in particular, it's often useful to extract noun phrases out of a sentence to get an understanding for what the sentence is actually about. So in today's problem, I'm going to be using a context-free grammar formalism to parse English sentences to determining their structures. So the objective is to basically use context-free grammar by repeatedly applying rewriting rules to transform symbols into other symbols. So the objective is to start with a non-terminal symbol, let's say S, representing a sentence, and then repeatedly apply context-free grammar rules until we generate a complete sentence of terminal symbols. In other words, words. The rules, let's say something like, let's go ahead and do S to NV. Well, what this would actually represent is an S symbol that can be written as NV. What exactly is this though? It's basically a noun followed by a verb. Let's say we have the rule N Prade and the rule V sat. We can generate the complete sentence Prade sat. But of course, noun phrases might not always be simple as words like Prade. So therefore we can have other phrases like my name or his name, for example. Those nouns can require more complex rules to account for. And for these type of rules, let's say my name, we can do something like NP to N. So this would represent a noun phrase to N. So that's more of how it works. But I'll actually be using a package, and it's called NLT. It's a natural language toolkit. And it's actually a leading platform for building Python programs to work with human language data. And in the program, I'll be employing the NLT's packages to help me solve this problem. And then let me show you some of the sample sentences that CS50 has provided. They've provided about 10 different sample files, which I can be using. So let's say 1.txt, for example. It's something simple like home sat. If we have 2.txt, it's home's lit a pipe. 3.txt, we arrived the day before yesterday. 4.txt, Holmes sat in the red armchair and he chuckled. 5.txt, my companion smelled an enigmatical smell. 6.txt, Holmes chuckled to himself. 7.txt, she never said a word until we were at the door here. 8.txt, Holmes sat and lit his pipe. 9.txt, I had a country walk on Thursday and came home in a dreadful mess. 10.txt, I had a little moist red paint in the palm of my hand. So we have all of these different text files, and then from there we'll be trying to manipulate an NLTK.tree object, which is how they say it, using trees and subtrees. Okay, let's start with the actual function then. Okay, let's play this. Okay, let's start. Python 3 parser.py 1.txt sentences 1.txt. Okay, see, here's a tree that we've generated from it. So our sentence is, of course, home sat. So from here, we've got the sentence, a subtree forming noun phrase and verb phrase, and from there we've got the noun homes, and from the verb phrase we've got the subtree v and then sat. So home sat. Okay, and here's our noun phrase chunks, homes. Let's do the other one, sentence 2.txt. From here is a more complex tree diagram that we can see. It's sentence, verb phrase, noun phrase, and it's broken down into more subtrees and that. Okay, we see two different functions, homes and pipe, and then let's go for another one. sentence 3.txt, we've got more, an even bigger tree, verb phrase, noun phrase, because it's quite broken down. Of course, sentence 3 was we arrived the day before yesterday, so we would obviously see so many. And det, if you don't know, means determiner. Otherwise, some words like the, of, these type of words, which can be quite common in these different sentences that we have. And then we have also the next one. Let's try 4.txt. An even bigger sentence tree. So, in fact, different sentences are even broken up in this one. So we have a noun phrase, verb phrase, and even in this case, we see adjectives and conjunctions and adjective phrases and noun phrases, etc. Or you would see in a normal one. And then let's try 5.txt. Let's just recap what was in 5.txt. My companion smiled an enigmatical smile. Simple, but still uses the same fundamentals. 6.txt. Holmes chuckled to himself like this. 7.txt. Okay, this is quite a big tree actually, and we have different noun phrase chunk, she, word, we, door, and these were the different nouns that they used in the sentences. If you didn't know, noun phrase chunks means that. And here we have all of this generated continually. As we use the NLTK model, we can generate more and more trees of different sorts, whether it's big or small, but we must of course define a set of words at the start before we can do it. Okay, I'll just give you a second to have a look at this diagram. Okay, let's move on to the next one, then the last one. Whoa, okay, seems to have generated some different diagrams. Let's have a look at this one, for example. I had a little moist red paint in the palm of my hand. Quite a big tree, we can agree. So that's that. And one last thing that that I'll show you is something that's in parser.py, the actual parser.py. Over here, if we take a look at parser.py, we've defined some simple terminals and non-terminals. So in essence, we have defined for us, a set of rules for generating terminal symbols. And in this case, it's the global variable called terminals. And then is the definition of non-terminals, which contains all the context-free grammar rules for generating non-terminal symbols, like what I introduced at the start, S2 and V, etc. And editing the non-terminal rules can be very useful and can be changed to any rule, such as, let's say, we can use something new like S2NP and just V, so noun, phrase, and verb, like name, his Prade, for example. And in this case, we can define any sentences as long as we have a set of predefined rules for generating terminal symbols. And that's that. But except for that, that's it for the video. Thank you very much for watching. I'll see you next time.